Hello, this is Jon Wood here, developer of Zero G Arena, and this is the first episode of what might be a fairly regular dev vlog, which will document parts of ZGA's development from now until launch. With any luck, launch should be in about 5 months or so, although any luck is generally too much to hope for when it comes to development time and deadlines. Anyway, with regards to the plan for the last few months of development, I've now got someone else working on the visuals, and that someone is none other than Mr. Max Graw, G-R-A-W, who you may remember as having made such community-made maps as most of them. Part of the vlog will be dedicated to showing his work on the art. Anyway, as well as significantly polishing ZGA's graphics, that gives me more time to work on more programmy stuff, in particular AI, which is probably going to take up most of my time between now and launch. Okay, so for those who don't know, I've decided to at least have a go at making an AI for Zero G Arena. I can't say for sure yet whether I'll be able to get a good enough result in an acceptable time frame, as ZGA introduces some major complications into the requirement for an AI. And for that matter, I haven't actually programmed a game AI of any kind before now. At this point I am fairly hopeful though, and I'm willing to give it several months if that's what it takes, as AI is, in my opinion, probably the most important feature I could add before launch. So anyway, on to my actual progress on the AI so far. I'm trying to implement the parts of the AI that are most likely to cause problems first, so that I can just cut my losses early on if it's not looking good with regards to time. Perhaps unsurprisingly, the potentially most problematic area by my current reckoning is likely to be navigation, so getting from A to B in the maps. As the AI will have to use pretty much the entire range of movement mechanics from a typical shooter, and also fly about with the grapple, and also accommodate for variable magnetic field directions. I've got a rough plan for the whole navigation system, and I decided to start with the subsystem for navigation on a single walkable surface within a single magnetic field. Okay, so clearly the AI is doing something there, and what it's doing is just picking a random location within its current magnetic field that it can get to without jumping or floating, and it's finding a path to that location around obstacles. The way that works is I've made a system for generating graphs which represent where the AI can walk. Those graphs basically consist of a bunch of nodes which just have a point in space, and those nodes can be connected to other nodes. Those connections are shown by the yellow lines you can see there, which is just something I set up for debugging. If two nodes are close enough to each other and there's an unobstructed route between them, then they're connected. The AI then knows it can walk between any two connected nodes. So to get from its starting node to a target node, it just has to find a series of connected nodes between them. As it so happens, algorithms for finding paths in graphs like this is a pretty well documented area in computer science. In fact, I actually remember doing a module in decision mathematics in school, which covered exactly this, although I obviously completely failed to appreciate the significance of it at the time. Anyway, I still remember studying it, but needless to say, I couldn't actually remember what I'd learnt on the subject of graph searches in school, so naturally I just copied the implementation of the A-star search algorithm from Wikipedia. Anyway, this is just the absolute beginnings of the system, so it has a lot of limitations I still need to iron out. For instance, you might have noticed that the AI has to take a zigzaggy path between nodes that aren't along a perfectly straight line, or on a 45-degree diagonal line. This is a bit of a limitation of using this kind of graph, but I plan to get around it by letting the AI do checks every frame or so to see if it can skip ahead to a node that it's got a clear path to. Okay, well I'm not sure exactly what my next step's going to be with the AI, but hopefully by the next video you'll be able to see some more advanced behaviour with the navigation system. Okay, so one of the things Max has been working on are some much needed visual and structural changes to the map Temple. And no, it's not themed as one of those indoor children's playgrounds. The brightly coloured areas here are just placeholders, as it's still very much work in progress. Anyway, the structural changes are more or less finished, and although I haven't had the opportunity to play the new version online yet, I think Max has made a lot of really smart changes, and I'm all but certain it's going to be more fun to play on. Here are some of the other models that Max has made improvements to, although some of them may well undergo further improvement before launch. All of the weapons have got a new look, which has served to unify the style between them all, and also restyle them to look more sci-fi. You'll see that some of them have new effects accordingly. Once again, I'm sure there might be further changes to the weapon models, but I really like the overall designs so far. We're going for a level of detail that's somewhere between minimalism and high detail, which to be honest is probably as much detail as you'd want for such a fast third-person game when it's in motion. Whereas previously the function of these boxes was ambiguous, now it is abundantly clear that it is to store energy. This is now official law. Lastly, Max has made these nice little cameras, and I've rigged them up to follow the player around the room. This is not to create the impression of a dystopian surveillance state so much as a televised sporting event.